You might be wondering, why did I decide to make a playlist on releasing your wild type through epigenetics? Well, quite frankly, I was inspired by, it was either Nietzsche or Ragnar Redbeard, I forget which one, but nobody would consider a cow to be, superior to a buffalo. Nobody would consider a Chihuahua, well, a Chihuahua isn't really that domesticated compared to, they're almost a wild dog, but nobody would consider a poodle to be superior to a wolf. And if you look at modern people do not seem all that superior to our wild counterparts in many ways. In some ways, we might be due to some of the achievements of our ancestors, but those achievements were made while our ancestors were in a far more wild state, even in the civilized times of Rome and Great Britain and things like that. And of course, in America, the founding of America, the pioneers were a return to the wild type, were a return to a sort of civilized barbarism, if you will, to colonize the United States of America. So nearly all domestic animals have shown to have smaller brains than their wild counterparts. Those that are most important to humans, mostly for consumption or companionship, display the greatest amount of reduction. These include pigs and sheep and dogs and cats, whose brains reduce more than twice as much as those of other domestics. Quantifying these changes has significant implications for assessing differences in information processing, the speed and mode of brain evolution, particularly since different sensory systems are variably affected in different domestic taxa. Okay, so cattle are globally one of the most populous and widespread livestock, and yet have not been examined for brain size change due to the extinction of their wild form, whatever, that's the wild form of cattle nearly 400 years ago. In many ways, however, cattle are a prime model for studying domestication. Genomic advances have highlighted the difficulty in identifying the wild ancestors of domestic populations, but the aurochs, which is another form of wild cattle, has been confirmed as the wild progenitor of all taurine cattle. Moreover, extinction has prevented introgression between the aurochs and domestic cattle for hundreds of years, which may mean a clearer distinction between wild and domestic populations. Brain reduction in specialized breeds. Brain reduction in domestic taxa has been consistently linked to two pillars of domestication: selection for tameness, meaning the more intelligent an animal is, the less likely they are to be pushed around. Okay, so selection for domestication, and selection for tameness and engagement with humans. Anatomical studies support this, reporting the overall brain reduction is driven by the reduction of the limbic system, a composite of brain region responsible for processing fear, reactivity, and aggression. Now, these are very important things: fear, reactivity, and aggression. Experimental studies also support a correlation between human engagement, behavioral selection, and reductive influence on brain and/or cranium. However, not all domestics are tame or equally selected for tameness, nor do they experience equal amounts of human exposure. Among domestic cattle, the bullfighting breed, Andalusian Black, is specifically selected for aggressiveness, while other breeds have no human contact throughout most of their lives. More so than other livestock, cattle breeds are specialized for a broad range of uses. These specializations correspond to different husbandry practices, which invariably correlate with different degrees of human contact and selection for docility. Consequently, cattle provide a model for testing whether the amount of brain reduction in domestics depends on the degree of docility or aggressiveness of different breeds. Most specialized beef and dairy cattle are bred under tailored human eye. yet both types differ greatly in the intensity and quality of human contact. A few breeds are bred for sport, like the bullfighting cattle, which are intensely selected for aggressive temper and a tendency to fight. The free-ranging park breeds, like the British White Park and Chillingham herds, referred to as wild white beasts, were originally enclosed for private sport or to decorate the landscape and are barely managed compared to other breeds. Most breeds, however, are now specialized and are used for a combination of dairy, meat, or draught. Wheat meaning to pull things. We sample listed, brain reduction and phylogeny. Sample of domestic cattle, material methods, wild versus domestic. Skull measurements were taken. Okay. Domestic cattle have 25.6% smaller brains than wild cattle, according to regressions of EV versus. So brain reduction in specialized breeds. Relative brain size varies widely among domestic cattle. This variation correlates with the primary use or selection pressure of specialized breeds. Confidence intervals, several regressions overlap. Okay. In relation to body mass from bullfighting cattle to dairy cattle, on the contrary, dairy cattle have significantly smaller relative compared to bullfighting cattle. The finding of small brains, so basically you have dairy cattle with much smaller brains than fighting cattle. The finding of small brains in dairy thus cannot be explained by dairy cattle having particularly wide muzzles, blah, blah, blah. But what I wanted to point out is you don't want to be a domesticated human. Cat brains are shrinking, and it's all humans' fault. Okay? This has to do, again, with us selecting for specific traits. Now, this has more to do with breeding, but it also has to do with epigenetics as well as genetics. Because remember, the two are intertwined. Just so you know, the bigger a baby's head, the more likely they are to earn a university degree. Just so you know, babies born with big heads are likely to be more intelligent, a study has suggested. Research has linked the size of a child's head with their academic achievements later on in life, finding that the bigger the head, smarter a baby will be. Okay. Genetics and intelligence. Intelligence is a core construct in differential psychology and behavioral genetics and should be so in cognitive neuroscience. It is one of the best predictors of important life outcomes, such as education, occupation, mental and physical health, and illness, and mortality. Intelligence is one of the most heritable behavioral traits. Okay, it is the most heritable behavioral traits. Here we highlight 5 genetic findings that are special to intelligence differences and that have important implications for its genetic architecture and for gene hunting expeditions. The heritability of intelligence increases from about 20% in infancy to perhaps 80% later in life. So what that means is you will notice the fact that children have the intelligences of their progenitors later in life. See, when they did research with Head Start many years ago, and they showed that Head Start does improve IQ in certain children, but it only lasts, their IQ drops again once they get into elementary school, like midway through elementary school. The reason why is because that small bump in intelligence is only temporary. So intelligence captures genetic effects on diverse cognitive and learning abilities, which correlate phenotypically about 0.30 on average, but correlate genetically about 0.60 or higher. Assortative mating is greater for intelligence, spouse correlations, than for other behavioral traits such as personality and psychopathology. Okay? Unlike psychiatric disorders, intelligence is normally distributed with a positive end of exceptional performance that is a model for positive genetics. Intelligence is associated with education and social class and broadens the causal perspectives on how these three intercorrelated variables contribute to social mobility and health, illness, and mortality differences. These 5 findings arose primarily from twin studies. They are being confirmed primarily where are we at here? These 5 studies arose primarily from twin studies. They are being confirmed by the first new quantitative genetic technique in a century. Nearly a century ago, intelligence was the first behavioral trait studied using newly emerging... You might be wondering, why am I putting this in here? It says IQ is hereditary, intelligence is hereditary. You'll remember in my last video, which I will go back to before I finish this one, the nutrients responsible for brain development, which are absolutely imperative that people have these proper nutrients so that the genes are expressed properly, so that the brain develops properly. Such studies have consistently shown that genetic influence on individual differences in intelligence is substantial. Intelligence has become the target of molecular genetic studies attempting to identify genes responsible for its heritability. Here we refrain from providing another general overview of the genetics of intelligence. We begin by noting 3 regularities that might almost be dubbed laws from genetic research. All traits showed significant genetic influence. No traits are 100% hereditable. Keep that in mind. No traits are 100% hereditable. Okay, so for some areas of behavior research, especially in psychiatry, the pendulum has swung so far from a focus on nurture to a focus on nature that it is important to highlight a second law of genetics for complex traits and common disorders. All traits show substantial environmental influence. All traits show substantial environmental influence in that heritability is not 100%, okay? This is where epigenetics comes in. Acceptance of the importance of both genetic and environmental influences leads to interest in the interplay between genes and the environment, or epigenetics, the interplay between genes and environment. Heritability is caused by many genes of small effect. The first 2 laws come from quantitative genetic research, which uses, for example, the twin method to assess the net contribution of genetics to individual differences without knowledge of the genetic architecture. A third law has emerged from molecular genetic research that attempts to identify specific genes responsible for widespread heritability, especially genome-wide association. What is intelligence and why is it important? Now, before I start this, I want to be sure that people understand. I actually am a firm believer in multiple intelligences, not the normal, which really IQ looks at multiple intelligences too, verbal ability, spatial ability, and numerical ability, but it's not as complete as the more complete multiple intelligences concept. So although there are many types of cognitive ability tests of individuals, they almost all correlate substantially and positively. People with higher ability on one cognitive task tend to have higher ability on all of the others. Intelligence, more precisely, general cognitive ability, or G, as discovered and defined by Spirit indexes, as long as a battery of cognitive tests is diverse and reliable, a general factor often represented by the first unrotated principal component, which is not strictly a factor. Intelligence is important
scientifically and socially, because intelligence represents individual differences in brain processes working in concert to solve problems. It is central to a systems approach to brain structure and function, and to the conceptualization of how diverse cognitive abilities decline with age. It is also one of the most stable behavioral traits, yielding a correlation of 0.63 in a study of people tested at age 11 and then again at age 79. Socially, intelligence is one of the best predictors of key outcomes such as education, occupation status. People with higher intelligence tend to have better mental and physical health and fewer illnesses throughout the life course and longer lives. The rest of this review describes 5 genetic findings that are special to intelligence differences: dramatic increases in heritability during the life course, high genetic correlations among diverse cognitive abilities. High is sort of mating the positive genetics of high intelligence and the impact of intelligence on social epidemiology. Okay, a new method of estimating genetic influence using DNA is a welcome addition to the quantitative, like other quantitative genetic designs, polymorphisms. Let's see what we got here. Heritability increases dramatically from infancy through adulthood. It would be reasonable to assume that as we go through life experiences, Shakespeare's whips and scorns of time have a cumulative effect on intelligence, perhaps overwhelming early genetic predispositions. However, for intelligence, heritability increases linearly from approximately 20% in infancy to 40% in adolescence and to 60% in adulthood. Some evidence suggests that heritability might increase as much as 80% in later adulthood, but then decline to about 60% at age 80. Most genetic research has been consistent with the dramatic increase in heritability for intelligence in the early human life course. Why does the heritability of intelligence increase so dramatically from childhood to adulthood? As seen in twin studies, a clear yet apparently contradictory finding constrains possible answers to this question. Despite this great increase in heritability, the same genes affect intelligence from age to age. For example, a recent twin study reported a genetic correlation of 0.75 standard error. Heritability. GCTA analysis in the same study, but using unrelated individuals, yielded a highly similar genetic correlation. Intelligence indexes general genetic effects across diverse cognitive and learning abilities. Another special genetic feature of intelligence is that its differences are caused by genes that affect cognitive abilities as diverse as, for example, spatial ability, vocabulary, processing speed, executive function, and memory. So you might be going, well, this is all about heredity, right? So I'm going to go back to talking about cattle here. People are animals. Okay, what we want to understand is that in order to reach our genetic potential, we need proper nutrients. So take time to understand the big picture, step back, and think about all you are trying to accomplish if you are working on genetic improvement within your herd, okay, or your family. It is not a good idea to short your cows during gestation. Because remember, nutrition is required during gestation so the genetic potential can be reached. Optimize health through nutrition. Cattle and humans require nutrients to support normal growth and development. Many times we focus on vitamin and mineral nutrition, but other important nutrients like protein and energy are also necessary for cattle and humans to reach their genetic potential. Know what your cattle and you are eating. It's hard to know whether you need to supplement protein or energy if you don't know what you are starting with in the first place. In comparison, we don't generally buy a bull without knowing his expected progeny. difference numbers. So why do we feed cattle without knowing the nutrients in the feed? This can be an important reason to track what you're eating or what you're feeding your loved ones, because you want to make sure that your food has the nutrients that it needs. Okay? Read your labels. Develop a nutrition plan. Ask for help. Go to a nutritionist. Go to a doctor. Go to somebody that understands nutrition. Okay? So I'm going to move on here. Remember, whereas all nutrients are needed for the development and function of the brain, certain nutrients have high impact on early brain development. All nutrients are needed for the development of the brain, but some are needed in higher amounts, and these include proteins and fats, iron, zinc, iodine, and vitamin B12. Also folate. I'm amazed folate wasn't included in there. Now, what do we remember about the diets of our primal cousins?
Even though the diets of primitive people differed greatly as to type and source, all diets provided a large increase in water-soluble vitamins over modern diets by at least a factor of 4, and at least 10 times more of the fat-soluble vitamins and mineral activators than the displacing diets of commerce. Quality rather than quantity was the important factor.
Let's hear that again.
Even though the diets of primitive people differed greatly as to type and source, all diets provided a large increase in water-soluble vitamins over modern diets by at least a factor of 4, and at least 10 times more of the fat-soluble vitamins and mineral activators than the displacing diets of commerce.
And I'm going to call it quits for this video. That'll be the end of this series, and I'm going to move on to another series about reclaiming the traditional American diet in the modern era.